God, you know, about 1989, right?
1980.
Yeah, it was so groundbreaking. And so yeah. So I'll say that.
Well,
yeah, this was just sort of notes. So I'm going to make an announcement first.
Okay,
then,
no problem.
And then I'll bring you.
Sure.
Okay.
Great.
Okay, please sit down. We're getting started. So first, I'll just make an announcement. So tomorrow, we're going to be in a different room at Cantor. There should be a map somewhere where you'll be able to find the location of that building. Okay, tomorrow, we're going to be in a different room at Cantor, and there should be a map somewhere in your package that tells you where it is. And at 12 o'clock, a bunch of AI safety speakers they want to host a networking lunch. And to talk about careers in AI safety. So this will be an opportunity for attendees, if you want to meet some of these leading researchers, to sort of meet them and talk to them. So if you are interested in doing that, it's going to be at around 12 o'clock. Just hang around the auditorium in the Cantor, the room we'll be in, and they'll come and find you. Or I think Jan here is, look for him. So that's tomorrow. Okay, so right now we're in this session on building morality into machines. The first speaker we have is Stephen Wolfram. He's one of my personal heroes because he's the creator of Mathematica. It's one of those really groundbreaking software back in 1988. He's also the founder and CEO of Wolfram Research, Wolfram Alpha, and the Wolfram language. And he's the author of A New Kind of Science, an elementary introduction to the Wolfram language, and Idea Makers. And I think he's also the youngest to have won the MacArthur Fellowship, if I got that correctly. And today he's going to talk about how to tell AIs what to do and what to tell them. Please join me. Welcome.
Okay. Well, thanks for inviting me here today. It's actually quite funny to be here because my mother was a philosophy professor in Oxford way back when. And when I was a kid, I always used to say the one thing I would never do was be a philosopher or talk about philosophy. So here I am. But before I really get into talking about AI, I thought I should say a little bit about my kind of personal worldview. I mean, I basically spent my life sort of alternating between doing basic science and building technology. And I've been interested in AI for about as long as I can remember. As a kid, though, I started out doing physics and cosmology and things like that. That got me into building technology to automate stuff like math. That worked out so well that I started thinking about, okay, like, how would one really compute everything about everything? And that was in about 1980. And at first, I thought I'd sort of had to build something like a brain to be able to do that, and I started studying neural nets and so on, but I didn't get very far. Meanwhile, I kind of got interested in an even bigger problem in science, sort of how to make the most general possible theories of anything. And the dominant idea for about 300 years had been to use math and equations and things to make theories in science, but I sort of wanted to go beyond that. And the big thing I realized was that the way to do that was to think about programs and the kind of sort of whole computational universe of possible programs. And if I can see if this wakes up. Wake up, computer. Okay. Let's see. Oh, there we go. There's one. Okay, so it's sort of a computational universe of an array of very simple programs. These are cellular automata. And studying these things led to sort of my personal kind of Galileo-like moment, which is, just point the computational telescope at these very simplest possible programs, and then turns out you see some amazing things. Like, for example, my favorite is this one called Rule 30 that just seems to, it's based on that very simple rule down at the bottom there, and it just keeps on going and just seems to keep on producing complexity forever from essentially nothing. So after I'd seen this, I kind of realized that it's actually something, this phenomenon of sort of being able to produce lots of complexity from almost nothing is something that kind of happens all over the computational universe, and for that matter, all over nature and the natural world. I think it's really ultimately the secret that lets nature make all the complicated stuff that we end up seeing in the world. It's something else, too. It's also sort of a window into what raw, unfettered computation is like. Well, at least traditionally when we do engineering, we're always sort of building things that are simple enough that we can foresee what they'll do. But if we just sort of go out into the computational universe, things can be much wilder. I mean, my company happens to have done a lot of mining out there in the computational universe, sort of finding programs that are useful for different purposes. Like, for example, this Rule 30 is really useful for making randomness. And modern machine learning, in some sense, can be thought of as sort of part way from traditional engineering to this kind of free-range mining of what's out there in the computational universe. Okay, but what can one say in general about the computational universe? Well, one thing one can say is all these programs out there can be thought of as doing computations. And, well, years ago I came up with this thing that I call the principle of computational equivalence that says that if the behavior of something isn't obviously simple, it typically corresponds to a computation that's maximally sophisticated. So there are lots of predictions and implications of this principle, like that, for example, universal computation should be ubiquitous out in the computational universe, and as should undecidability. And it also implies a phenomenon that I call computational irreducibility. So if you look at a sort of typical complicated case of this is a very simple program, this is what it does, can you predict what it's going to do? You know, are these little streamers going to go on forever? Is it eventually going to die out? What's going to happen? Well, this is an example of a phenomenon that is probably computationally irreducible, which means you can't figure out what it's going to do without effectively tracing each step and going through sort of the same computational effort to work out what's going to happen as this system goes through itself to work out what it's going to do. So it's a completely deterministic system, but to us, it's got what seems a bit like free will because we can never know what it's going to do. So here's another thing. We think about, in this kind of context, about what intelligence is. Well, our sort of big unifying principle, this principle of computational equivalence, says that everything from sort of a tiny program to our brains should be computationally equivalent, which means that there's sort of no bright line between intelligence and mere computation. I mean, when we say something like the weather has a mind of its own, that has some truth to it. It's doing computations that are just as sophisticated as the computations that are going on in our brains. Well, to us, though, it's pretty alien computation because it's not connected. What the weather is doing isn't connected to its form of computation or intelligence isn't connected to our human goals and experiences. It's just a sort of raw computation that happens to be going on. So the question then is, so how do we tame computation? We have all this stuff that can happen out there in the computational universe. How do we mold it to our goals? Well, the first step is to describe our goals. And actually for the past 30 years or so, what I've basically been doing is trying to create a way to do that. I've been building a language that's this now called Wolfram language that has its homepage, that allows us to kind of express what we want to do. It's a computer language. It's not really like any other computer language because it's, in a sense, much crazier. Instead of sort of just telling a computer what to do in its terms, the language tries to build in as much knowledge as possible about computation, about the world, right into the language so that essentially we humans can describe in our terms what we want to do, and then it's up to the language to get those things done as automatically as possible. Well, that basic idea has worked really well, and in the form of Mathematica, it's been used to make endless inventions and discoveries and things over the years. It's also what's inside Wolfram Alpha, where the idea is to take pure natural language questions and understand them and use the kind of curated knowledge and algorithms that our civilization has produced to be able to compute answers to these questions. And yes, that's a sort of very classic AI-ish thing, and in practice, it's, of course, computed answers to billions and billions of questions from humans, for example, in Siri and other places. So I actually had an interesting experience recently figuring out how to use what we've built in our Wolfram language to teach computational thinking to human kids. And I was writing a book about this, and I was writing exercises for the book. And at the beginning, it was really easy to write these exercises. The basic form of an exercise was make a program to do X. And it was pretty easy to say what X was in kind of English. But later on, it was much more frustrating because it was like, I know exactly what I'm trying to get people to do. I can express it very easily in the Wolfram language, but it's really hard to express what I want done in English. And I realized, gosh, this is why I just spent 30 years developing a language to express things. Well, so English has about 25,000 common words. The Wolfram language has about 5,000 kind of carefully designed built-in constructs, including all the latest machine learning stuff and so on, together with millions of things based on sort of curated data. And the idea is that once one can, the sort of concept, the goal is, once one can think about something in the world computationally, it should be as easy as possible to express that thing in the Wolfram language. The cool thing is, it seems to really work. I mean, humans, including kids, can write and read the language, and so can computers. It's kind of a high-level bridge between human thinking and its whole sort of cultural context and computation. Okay, so what about AI? Well, technology has sort of always been about finding things that exist in the world and then kind of taming them to automate achieving some particular human goals. And in AI, the things we're taming are things that sort of exist in this computational universe of possible programs. Well, there's a lot of kind of raw computation kind of seething around in that computational universe of possibilities, just as there's a lot of complicated computation that we don't necessarily understand that's going on in nature. But what we're interested in is computation that somehow relates to our human goals. Okay, so we want to talk about ethics. So maybe the way to think about that is we want to constrain this computation, this AI process, to only do things that we, let's say, consider ethical. But somehow we have to find a way to describe what we mean by that. Well, in the human world, one way we have to do that, at least partially, is with laws. So one question is, how do we connect human laws to computations? We call them legal codes sometimes, but today laws and contracts and things like that are basically written mostly in natural language. I mean, there have been simple sort of computable contracts in areas like financial derivatives for a long time, and now one talks about smart contracts in the context of cryptocurrencies and things like that. But what about sort of the vast mass of law that exists out there? Well, I mean, Leibniz, for example, who died 300 years ago next month, actually, was always talking about making kind of a universal language to, as we would say now, express all of law in a kind of computable way. Well, he was a few centuries too early, but I think now we're actually finally in a position to really do this. I mean, I just actually posted a blog a couple of days ago about this, but I'll try to, this is a long, long blog, but I'll try to summarize some of the things that I talked about there. So, I mean, with what we've already done with the Wolfram language, we've managed to express a lot of kinds of things in the world, like the kinds of things that people, ask Siri about or something like that. And I think we're now within sight of what Leibniz wanted, which is to have a general sort of symbolic discourse language that represents everything that's involved in human affairs. So I see the basic issue of building this as a language design problem. I mean, yes, we can look at natural language to get clues, but ultimately we have to build sort of our own symbolic language if we want to be able to create sort of this computable system. It's actually basically the same kind of thing that I've done for ages and ages in designing the Wolfram language. I mean, take even a word like plus. Well, in the Wolfram language, there's a function called plus, but it doesn't necessarily mean the same thing as the word. It's a very specific version of meaning that has to do with adding things mathematically and so on. Well, as we design a symbolic discourse language, it's going to be the same kind of thing. I mean, we can take, the word eat in English, for example, can mean lots of things. But we need a concept that we'll probably refer to as eat that's a very specific version that we can then compute with. So let's say we've got a contract that's written in natural language. Well, one way to get a sort of symbolic version of it is to use some kind of natural language understanding system, just like we do for all those Wolfram Alpha inputs. And sometimes we have to ask humans about ambiguities, which Springfield did you mean, and so on. Well, another thing we might do to get from our sort of original representation to the symbolic representation, we might have a picture, and we might use machine learning to generate a description of that picture in the form of this precise symbolic language. But ultimately, the best way to actually know what you're trying to write is to write in this symbolic language in the first place. And I'm kind of guessing that the lawyers of the future will spend a lot of their time writing in some kind of symbolic discourse language mechanism. Well, okay, so once you have a contract in sort of symbolic form, you can start to compute about it. You can automatically see if it's satisfied in a particular set of situations. You can simulate different outcomes. You can automatically aggregate together bundles of huge numbers of these contracts and figure out statistically what's going to happen and build all kinds of funky financial instruments out of them and so on. Well, ultimately, though, a contract has to get input from the real world. Some of that input will be born digital, like data about accessing a computer system or transferring Bitcoin or something. Often, though, that input will have to come from sensors and measurements and so on from the real world, and it will take basically machine learning kinds of methods to turn those measurements into something symbolic. We'll have to, that's sort of where those judgments come in. Well, if we can sort of express laws in computable form, maybe we can start sort of telling AIs how we want them to act. It might be better if we could sort of boil everything down to, Asimov's laws of robotics, or the idea of utilitarianism, or some such other thing. But I don't think anything like that is going to work. I think what we're ultimately trying to do is to sort of find perfect constraints on computation, but computation is something that's in a sense infinitely wild. So let me give you an example of what I mean by this. I mean, the issue already shows up in, for example, Gödel's theorem. Like, let's say we're trying to look at integers, and we're trying to set up axioms that constrain us to be just talking about the everyday integers that we thought we were talking about. Well, one of the things that Gödel's theorem shows is that there is no finite set of axioms that you can construct that constrain things so that you guarantee to be just talking about ordinary integers. There'll always be some wild form of thing that isn't what we'd ordinarily think of as an integer that is still consistent with those constraints, those axioms that you've set up. Well, actually, this phenomenon of computational irreducibility that I mentioned implies a much more general version of this. Basically, given any set of laws or constraints, there'll always be, in a sense, unintended consequences. It's not particularly surprising if one looks at kind of the evolution of human law that something like this would be true, but the point is that there's sort of theoretically no way around it. It's a feature of sort of just what happens in the computational universe. It's ubiquitous in the computational universe. Now, I think it's pretty clear that AI is going to get more and more important in the world and sort of eventually going to control much of the infrastructure of human affairs, kind of a bit like governments do now. And like with governments, perhaps the thing we'd like to be able to do is to sort of create an AI constitution that defines what the AIs should be doing. So the question is, what should this constitution be like? Well, it's got to be based on a model of the world, and inevitably a sort of imperfect model. And then it's got to say sort of what to do in lots of different circumstances. And ultimately, what it's got to do is provide a way of constraining the computations that happen to be the ones that align with our goals. But, okay, so what should those goals be? Well, I don't think there's any right answer to that. In fact, one can sort of enumerate goals just like one can enumerate kind of programs in the computational universe. And there's no abstract way to choose between, this goal is better than that goal and so on. But for us, there's a way to choose because we have a particular biology and we have a particular history of our culture and our civilization and so on. It's taken sort of a lot of irreducible computation to get here. But now that we're just at this particular point in the computational universe, that corresponds to the goals that we have. So, human goals have clearly evolved a lot through the course of history, and I suspect they're about to evolve a lot more. I think it's sort of pretty inevitable that our sort of consciousness will increasingly merge with technology, and eventually, certain scenario is that, you know, our whole civilization will end up as something like a box of 1 trillion kind of uploaded human souls. But then the big question is, okay, well, what will these uploaded human souls choose to do? Well, the bad thing is probably we don't even have a language yet to describe the answer to that. I mean, if we look back even to Leibniz's time, we can see all sorts of modern concepts that hadn't formed yet. And when we look inside, for example, a modern machine learning system, it's, or for that matter, a theorem-proving system, it's very humbling to sort of see how many concepts those systems have effectively created that we haven't yet absorbed in our culture and for which we don't have any words or other ways to describe them. So maybe looked at from our current point of view, it'll seem like those kind of disembodied virtual souls are just sort of playing video games for the rest of eternity. You know, at first maybe they'll operate in sort of a simulation of our actual universe, then maybe they'll do something that I've enjoyed doing, which is to go out and start exploring the computational universe of all possible universes. But at some level, all they'll be doing is computation, and the principle of computational equivalence says it's computation that's fundamentally equivalent to all other computation. It's kind of a bit of a letdown. I mean, you know, the proud future of this whole civilization that we've built ends up sort of being just computationally equivalent to, you know, plain physics or little Rule 30 or something like that. Of course, in a sense, that type of conclusion is just an extension of kind of the long story of how science keeps on showing us that we're somehow not fundamentally special. We can't sort of, and that, in a sense, we can't look for sort of ultimate meaning in where we've reached through sort of the processes of history that we've gone through. We can't define a kind of ultimate purpose or for that matter, an ultimate ethics. And in a sense, we sort of have to embrace the details of our existence and our history. So I think my conclusion is that there won't be sort of a simple principle that encapsulates what we want in our kind of AI constitution. There'll be lots of details that reflect the details of our existence and our history. I mean, the first step is just to sort of understand how to represent these things, which is what I think we can now start to look at doing with something like a symbolic discourse language. And yes, conveniently, I happen to have just spent 30 years building the framework to create such a thing. And I'm keen to understand how we can actually use that to start creating things like an AI constitution. Well, I thought I better stop talking about philosophy here. Usually I spend my time building technology, but I'll stop here, and I hope there are questions and comments and things. Thanks.
Hello, Peter Voss here. I'd be curious to know what your best guess is as to when we'll reach human-level intelligence in AI. So, when will we reach human-level intelligence? You know, I've been working on AI kinds of things for probably 35 years, and people keep on saying, when the system is able to do X, then we'll be really impressed. And, you know, I've done quite a few of those X's through technology that I've built. And it's kind of disappointing because people aren't that impressed. You know, I think the main point is that the disembodied intelligence is something that we reached long ago. Disembodied intelligence is just computation. The issue is it intelligence that we recognize as being human-like intelligence? And that's really a question of exactly how we kind of, how we imprint kind of human-like things on this computation that we, in a sense, already have. So I think it's very much in the eye of the beholder, and I think there are questions about how human-like the experiences and operations of the thing have to be in order that we recognize it as human intelligence. There's really a very close analogy between extraterrestrial intelligence and artificial intelligence. You know, we see it's like, okay, how should the stars be arranged so that we know that something intelligent arranged those stars? Well, there are many ways stars would arrange themselves with gravity or whatever else. There may be some incredibly intelligent arrangement of stars out there, but it doesn't relate to our human notions of intelligence, and so we don't recognize it as such. And I think it's the same type of thing with AI. So I think it's a deeply slippery issue.
Hi, my name is Chris Howder. I'm an alumnus of Columbia University. The question is about the Wolfram language. So putting on asking the language designer, implementer part of you, what were the sorry, this question is about the symbolic discourse language, the new language you're creating. Based on your experience over the last 30 years building the Wolfram language, what are the difficulties, whether implementation or theoretical, scaling difficulties, parser, lexer, AST, interpreter, etc., that you foresee will be problematic in the development of the symbolic discourse language? And finally, this is an open-ended question, so answer it as you will.
Yeah, so I mean, the thing that's language design is really hard. I mean, I've worked on a bunch of different things that people think are hard, like physics and math and other such things. Language design is really hard compared to those things, because it pushes you right into having to really understand things with maximum possible clarity. I mean, what you're trying to do when you design a language, you're trying to design a framework for people to think in. I suppose a little bit like philosophy has tried to do, but as a language designer, you don't get to just write essays about these things. You actually have to implement stuff, and then you have to stick with what you implemented. So it's really, drilling down. I view the role of a language designer more or less as this. When you're thinking about computation, you're imagining all the possible kinds of computations people might want to do, and then you're working a bit like a natural scientist. You're kind of drilling down underneath what you see people want to do to find what primitives exist that you can then build up from to let people conveniently create what they want to do. Well, I think the symbolic discourse language, it's the same kind of thing. We have to look at sort of everything that's out there in sort of the world of human affairs and so on, and we have to say, what are the fundamental concepts? How should we best slice things up? And, people like in the 1600s, it was quite a popular thing to do, to invent philosophical languages. There's a chap called John Wilkins who had one of the better developed philosophical languages, which was an attempt to kind of do this sort of thing of slicing up concepts in the world in some way. Well, the hard thing, I think, is actually doing that. And it's something where, in a sense, to do it, you have to take a flying leap and just start doing it. Because there isn't really, it's not like there's a big framework that already exists. It's just you've got to start deciding how it's going to work, as people have done, when it's Roget making up his thesaurus or something like this. But I think that's the main difficulty is just that you have to understand things clearly and be able to drill down there.
I think we have a question over there.
Yes.
And there's one here, and then
Hi, over here. I'm just curious, do you think we live in a deterministic universe? And tangentially, what are your thoughts on this question of whether our present reality is a simulation or not?
So I've worked quite a bit on fundamental physics. The tantalizing thing is when you see these simple programs like the accelerometer that I showed, and you see how tiny their rules are, and you see how complicated what they do is, you start thinking, well, gosh, maybe our whole universe is like that. Maybe there's really some simple rule underneath our whole universe. If we think about our universe being determined by a program, we might, the program might be the size of an operating system, millions of lines of code. Seems implausible. More likely, it's something short. That's a weird claim in itself because it's kind of very anti-Copernican. Copernicus kind of has sort of taught us that we shouldn't think of ourselves as special in some way. So why should we get the universe that's the special one that has a simple program? In terms of kind of thinking about simulation, is our universe as it is now existing a simulation? I think that argument is a muddle, okay? Because the way I see it, this question, okay, you asked about determinism. When you say something is non-deterministic, what you're saying is, I don't know everything about how this system works. There's something outside the system that is randomly kicking this system. There's a part that I know that's deterministic, and then there's the non-deterministic part that's kicking it. That's kind of a wimp out when you're trying to make a theory in science. And so, the question is, the first cut is, let's just say maybe our universe is deterministic. Maybe there's just a rule, an initial condition. Maybe everything that happens, the question you ask, the answer I'm giving, is all ultimately determined by those things. I think that's a good first hypothesis. I don't know any way to prove that isn't true, so that's a hypothesis that I'm working on. In terms of I think it is quite plausible that there is just a simple deterministic rule that determines how the universe works. It's kind of like the digits of pi. There's a simple deterministic rule that determines them, and then you generate all those digits, and it's like you generate our whole universe, and here's everything that happens, just like we see all the digits of pi. Now, you say, well, what would it mean if there's a simulation going on there? Underneath, down at the Planck scale, there's this whole civilization that's arranging things very carefully to make our world be the way it is. But actually,
they're stuck in the same deterministic system too. So the question of whether there is something down at the Planck scale that's a whole civilization comes exactly back to the previous question that was asked about intelligence, actually. It's a question of how do we tell, you know, it's like we're searching for extraterrestrial intelligence. It's not extraterrestrial, it's everywhere inside our universe, but we're searching down there and we're saying, is it intelligence? Is it a civilization? Or is it just physics, so to speak?
Hi, my name is Jim. I didn't major in philosophy either, but since we're on that kind of spirit, I have a philosophical question as well. It's in the similar spirit as the previous question. So if you think the universe is computational in some nature, how do you, what's your best hypothesis on how consciousness arises out of this fundamentally computational universe? And on that topic, I guess, whether you think free will exists and the whole related philosophical conundrum.
Whether we really exist, you're asking?
No, whether free will exists and how consciousness arises from computation.
Okay.
I think the word was brought up.
I mean, the first statement about free will is that I'm really pretty sure that the way we, free will and determinism, work together is through this idea of computational irreducibility. That even though there is determinism, you can't know what's going to happen any sort of faster, more easily than the system itself. So the system itself it's like deciding what to do, and we're trying to say, no, I know what you're going to do. You don't have free will. I know what you're going to do. Actually, you can't tell what the system is going to do except by just following through exactly what it does. And you can start tracing through all the sort of implications of free will about responsibility and so on. Is this system responsible for its actions? Well, actually it is. It's more responsible for its actions than if you say there's a system which is being kicked by the outside world in certain ways, that's being sort of, the environment is forcing it to do this or that. Now you ask about consciousness and so on. I hate this term because I think, if you look at the sort of stack of different things that start from life, go to intelligence, then you get to consciousness and so on, every one of them has the following feature that, let's take life as an example, okay? So how do we define life? What is alive, what is not alive? On Earth, it's pretty easy. There's shared history to everything. Everything that's alive has RNA in it. That's a very specific thing. It's probably not the general abstract notion of life, that life has to have RNA in it. But we don't really have a good abstract definition of life. People have tried different definitions. They never really work. And the reason is, I think, because ultimately the only thing is that there's sort of sophisticated computation going on, but there's nothing that defines life except by this sort of historical definition. I was saying the same thing about intelligence, and I think it's even worse with consciousness.
Last question,
Yeah, I have two questions. One is, I'm really surprised that you think that free will has something to do with unpredictability, because I think most philosophers wouldn't say that they wouldn't deny, first of all, that something or someone was acting freely simply because it was predictable that they would do something. Because, let's say, a completely rational person, you can predict what they'll do, but you wouldn't necessarily on that basis deny free will. But the major point I was concerned with is when you talked about any given set of constraints as rules will always lead to unintended consequences. Sometimes philosophers distinguish between a rule and a principle, so that it's something like the difference between the letter and the spirit of the law. So you try to set up a set of rules, okay, and you find yourself, when you deal with certain cases, okay, in the law, that the rule leads you to peculiar consequences, all right? There's something wrong, all right? You haven't captured what you had hoped to capture. But you understand that because you understand a principle that lies behind the rule. And I'm wondering if there's anything like that that is computable for AI, namely that they see the peculiarities the rule will generate, but they understand the principle behind it. I mean, a simple example is, H.L.A. Hart talked about rules that said cars should not be driven in the park, and then somebody has a toy car. Well, there's obviously the intent of the law is not captured by the rule, and we understand that, and is there something comparable?
That's interesting question. So I mean, I think, well, first of all, about free will, I'm not a professional philosopher. I decided not to do that when I was 5 years old or something. So I can't debate all the details of how philosophers talk about free will. Although there's a lot more that I could say than the few sentences that I just said. In terms of sort of the intent, the principle, as opposed to the letter of what's going on, in a sense, what one does when one sets things up computationally, when one talks about symbolic systems and so on, is one's trying to grind out all of those sort of humanistic types of things and sort of desiccate everything to the point where it is just a bunch of symbols and where there is something definite that can be said. Now, if you ask the question, can there be more general principles? In other words, you've got some particular set of rules, let's say, is there a more general principle at work? Let me give you an analogy, okay? In mathematics. So in mathematics, there is, in a sense, we can prove that there's sort of an infinite frontier to mathematics. You will prove certain theorems, but there'll always be more theorems to prove. There'll always be more, in a sense, principles to discover. You'll never reach the edge of the principles that there are to discover. In fact, it's sort of a consequence of this computational irreducibility idea that there'll always be more to discover. So I'll give you an example. Let's say we're looking at physics, at the universe. What can we build in the universe? Can we build a spaceship with warp drive, something like this? We may be able to just straight answer that question, but there's no guarantee. It's kind of an undecidability type thing. There's no guarantee that given the building blocks that we have in the universe, there may be no sort of finite way to decide whether we can build a spaceship that will support warp drive. And it's the same type of thing, I think, with this question about, you're asking about, can there be a deeper principle? Can one discover a deeper principle? I think a consequence of this principle of principle of computational equivalence and computational irreducibility, I think a consequence is there will always be deeper principles. Can one get to the point where there will never be an ultimate principle or a lowest principle, but there will always be more that can be discovered. Like in mathematics, you won't reach the edge where you just say, now we understand everything. We've got the complete set of rules where we've got everything nailed down. There'll always be more that can be discovered. It's an interesting question, and there's probably more that I'm not. Just one more comment about this, okay? The thing that happens, for example, when you look at the output from an automated theorem proving system, you can establish that something is true, but what you see is a bunch of little sort of atoms of fact there. It is not something that humans can relate to, because there are no sort of waypoints that are, Smith's theorem, Jones's theorem, that everybody knows what they are. There are no kind of things, concepts that have emerged that we understand. And I think when you talk about principles, I think in part what you're maybe talking about is these kinds of things that have emerged as culturally known things to us that, and I think one of the things that happens in this sort of computational world is that you get all these little bits of computation, and the question of whether we can understand parts of that in some way where we can talk about them is a different and sort of more, it's more a question about human history than it is about the raw computation. Okay, thanks.
I know I missed some people, but there'll be a panel at the end, so you can ask your question then. So thank you. So next off, we have Professor Francesca Rossi. She teaches at University of Padova and is a computer scientist. She's the president of the International Joint Conference on Artificial Intelligence and is associate editor-in-chief of the Journal of Artificial Intelligence Research. And today she's going to talk about ethical embodied decision-making. Welcome.
Okay. So the point that I want to make with this talk is that in order to help people make a very good decision close to optimality, we need to have both these features. We need to help them in an embodied environment, and I will explain a little bit what I mean by that. And we also need to make sure that the process of decision making and also the result of the decision-making process is going to follow some ethical principles. So in order to talk about this, I will start from a document that has been published very recently, 2 days ago, from the White House. It's a document that describes the strategic plan for AI. And it contains the description of the goal of the strategic plan, and the goal is to produce AI which is beneficial to society while minimizing the negative effect. And I think that this is the goal of many of the events that we have all been participating, and many of the initiatives, including the partnership initiative that I'm part of that was mentioned before, and that I will come back to it later on. So I think we can all share that goal. And to achieve that goal, this document describes 7 lines of 7 directions, 7 strategies. One is related especially to a funding agents, like a government should be, which is to have long-term investments in AI research, because we need to understand not just the short-term implications and results that we can get, but we also need to think, as many people have mentioned today, we also need to think at the impact in the long term. Another one is the issue of human-AI collaboration. So it has to do, with the fact that AI systems will work with us, together with us, in the environment in which we function, and I will get back to that. The third one is to try to understand also the ethical, legal, and societal implication of the use of AI system, including how to make them aligned in terms of values and ethics to our values, human values and ethical principles. Then, the fourth one has to do with building AI systems that are safe and secure, in the sense of that they can be reliable in our eyes, they can be dependable, we can have trust into these AI systems, because otherwise we would not be able to relate well to them if we not trust them. And the fifth one has to do with doing things in the open. A lot of many successful AI approaches, especially those based on machine learning, we know that depend a lot of the data that is used to train those systems. So it's important that these data sets are public and available and known, also to build that trust that I mentioned before. The sixth one has to do with, evaluate how we are going to evaluate AI and assess the real, capabilities of an AI system. And the seventh one, of course, is the implication onto the workforce. And in this talk, I will mainly touch upon these three strategies in the middle. So I will describe and stress a lot the issue of human-AI collaboration more than the autonomous AI, which of course has a lot of value, but in this talk I will mostly talk about human-AI collaboration. The ethical and legal and societal implication of AI, and how to embed these ethical principles, or questions about how to embed these ethical principles, I don't have many answers, of course, into these AI systems that collaborate with humans, and then how to build trust into these systems. So let's start with human-AI collaboration. So the idea here is that the focus is on systems that are not going to replace our intelligence, but are going to actually augment our intelligence. So in terms of decision-making, which is the area that I've been working for many years in the past, the idea is not to make decisions instead of humans making decisions, but to help humans make better decisions. And this can be done when a single individual has to make a decision. We're going to help that single individual to make a better decision, whatever it is that is doing, whether in his private life or professional life, or also helping a group of people to make decisions, which is a bit more complex task. And of course, in order to do that, you have to put together a system which is not just a human, it's not just an AI system, but is a human and AI system, or a group of humans and AI systems together. And as you see here, that's a typical example that is given, that in many scenarios, for example, in chess, people say that most of the time, now it's recognized that humans plus machines playing chess play better than the human alone or the AI system alone, but also in more useful applications like diagnosing cancer, it has been seen that the error, which can be small in both the human alone or the AI system alone, but if you put them together, it becomes even smaller. This means that humans and machines are really complementary in their limitations, so they can help each other in really achieving a better performance in terms of, for example, diagnosing cancer in this way. So I really think there is a lot of interest, from society, a lot of beneficial implication in trying to focus not only on this, but trying to understand how to make in the best way these human-machine collaborative systems. And of course, to have a natural and effective interaction, of course, we need to understand what it means for this human and machine to work together. And we need to understand how to model the human, how to elicit its preferences, his opinions, its desires, what is the goal that he has to do. We need to be able to have awareness from the AI system of the context in which the human is functioning, and the context not just in a static way, but also over time, remembering what was done in the past and how decisions were made and what the implications of those decision consequences been, so that we can improve over time. We want systems that are proactively providing information to the human and not just on request, because they can help much better in that way. They can alert when things are not going well. For example, on the ethical side, they can alert humans and help them being, for example, more ethical. Now I'm anticipating going to the ethical side. But of course, humans, that we have all our ethical principles. We may have all our ethical principles, but sometimes we are a bit confused and we don't follow them just because things are reworded or redefined in a different way. So definitely there is a way for a human-AI collaboration here. And also they have to be able to sense our emotions, our way of moods, our way of functioning that particular day in that particular context. So they have to have some sort of emotional intelligence, and they have to be able to interact with us in a very natural way. So real-time dialogue, interaction, natural language and processing, and so on. So this is the desiderata, I think, of a human-AI collaborative system. And I claim that this desiderata can be, of course, we can try to implement this desiderata into an app, into our phone, or into a system that we can open the laptop and use it. But actually, I think the future is not of people opening a laptop and using a tool, or people using an app on my phone. It's of people walking around in whatever environment they are, and that environment recognizes them, remembers their preferences and opinions, and observes what the humans do, sees if he needs help in whatever task is approaching in that particular context, and provides information and helps the human make decisions. So I think the best way to help people make better decisions is within embodied environment. And the environment, of course, the fact that you have an embodied environment is that the environment is always with you. Wherever you go, the environment follows. And of course, it is related to the Internet of Things thing, where everything will be linked to each other. So you are not going to close a little laptop somewhere and then open it somewhere else, and then you have to say, oh, by the way, these things happened in the meantime, and then you need to remember this because this is going to affect my next decision. But the information will always be there with you. And there are also going to be situations like a surgery room or a cockpit of a plane in an emergency situation. So you humans are already in
embodied environment all the time during their private or professional life. So it would be not reasonable to not exploit these or embodied environments that are already there, especially when you need the real-time decision in a very fast time and with critical results and consequences. So the environment should be able to see and listen to the human, so perception capabilities, remember, having memory, remember all the past actions and decisions, collect the human preferences in a dynamic way, and possibly not just monotonic and accumulating, but resolving conflicts, because humans can change their preferences of opinion over time. And then exploit, I think that the embodied features on the environment could really be exploited to have a better natural interaction. For example, we know that dialogue, natural language dialogue between a human and a system is not really at a very advanced level. Question answering is, but dialogue is not really, we cannot really dialogue, meaning, several questions one after the other without having to repeat the context from scratch all the time. So the dialogue capabilities, I think, would be much supported and helped and improved by having an embodied environment. Because, for example, if this room were, an embodied environment where, with cameras that can see where I am, what I say, where I look at, where I point, then some pronoun resolution, for example, that are not easy, that would be easier by just looking at where I point and where I look at. Okay? So the information in this embodied environment where humans will be helped in making decisions will flow in two different directions. From the environment, which is going to provide, provide data in the right way, format for human to understand. It's going to provide suggestions for possible decision. It's going to provide capabilities for resolving conflicts if it's a group decision-making, like a hiring committee. So flows of information will go from the environment to the humans, but also information will go from the humans to the environment by providing, with my gesture, with what I say, it will collect my preferences and will be used during the decision that I have to make now, today, but also tomorrow, because it will be remembered over time. So now let's go to the other objective that I use, which is about ethics. And of course, we don't want just humans to make better decisions, where better means more efficient or more operationally more close to optimality. But we want it to be decisions that are going to be aligned with our ethical principles. And when I say ethical principles, I know it's a very vague word, and probably I use it in the wrong way because I'm not a philosopher, but I mean a very wide set of things, going from the ethical principles that philosophers talk about to moral values and so on, but also to some social norms, to some behavioral rules that we usually follow in a certain context, or even professional codes, laws, traditions, cultural-based behaviors that we have, maybe, so I mean many different things that then will be specific, then will be specialized and in particular contexts, and when I'm doing one particular task. And so it's important, of course, that these principles are not just stuck into the system at the end, when the system of decision support system is already constructed, but they should be there since the beginning of the design phase. So there is this, engineering part of AI safety that should be really part of the whole process, from the initial design of the decision support system to the end when the thing is actually deployed to the real world. We know that it's not that clear yet how to embed ethical principles into these systems. Of course, it would be very nice if we could write some rules, well-defined rules, and then once we have rules, as was mentioned before, of course we can computationally write these rules in a way that a program can, a language can describe, and then we can implement them and so on, and then the system can follow the rules. But most of the time it's not like that. First of all, because rules may change, and also because we don't have rules, but as mentioned before, we have mostly principles. Like take a doctor has to follow the Hippocratic Oath when he makes decisions. The Hippocratic Oath is very vague. Many things are not said, and so we don't have a set of rules that the doctor has to obey every single minute of his professional life. It is, of course, possible then to say, okay, I don't have rules, so then let's look at the doctor. Let's look at the way it works. Let's look at the way he makes decisions over time, and then I will learn more or less these principles and rules by observing the doctor, like an inverse reinforcement learning idea. And this is also, a possible approach, but I mostly think that the two approaches should be combined, because sometimes you have some rules, maybe with a lot of holes here and there, and then you can fill the gaps in that. But I think that this is not enough, and what is needed is also something that we don't know how to describe, which is common sense. And as also Ian mentioned before, we do many things and we predict many things of behavior of other people because we have, we know how the world works. We have common sense reasoning inside during our, several years of life. We have built this common sense reasoning inside us, and nobody gave us some rules, but we just built them by observing others, by looking at the consequences of our actions, and by doing many, many methods to acquire this common sense, and we still don't know how to put it into machines. So two different doctors, both following the Hippocratic Oath principles, they maybe behave in very different ways, given the same patient with the same history, just because, they have maybe different ways of implementing the Hippocratic Oath into their real life, professional decisions. It may also depend on where they are. Maybe a doctor in Europe will behave different than a doctor in the United States, So there are many different dimensions along which that make this task complex. But mostly in this AI, human collaborative system that I'm talking about, this ethical, we need to make sure that really there is value alignment. And the reason why we want to do that is because we want to trust these systems. If we don't trust this system, if we not trust them at the right level of trust, then we are going to have very, non-optimal results. We don't want to over-trust the system, of course, because otherwise we are going to expect some good behavior when the system does not have the capability to perform that way. But we don't want even to under-trust the system, because otherwise we won't be able to exploit the full capabilities of what the system can give us in terms of helping us make decisions. So building trust is very important, and is not something, again, that is static. Even between humans, you don't build trust just the first time you meet somebody. You build trust over time by looking at how that person behaves, whether it's reliable, whether you can explain why he's doing something and why he's not doing something. And in this case, if it's not making decisions, suppose that the AI system is not making decisions, but just suggesting decisions, it has to tell me, why are you suggesting that therapy with that patient and not another one that I would suggest? Maybe you have read more text, in scientific articles, then you tell me which is the article that is going to, explain why you're doing that. And so the role of explanation is really very important. And possibly over time, when we interact with this AI system, over time possibly the explanations will be less and less important. Because once you build trust, then you understand that the system behaves according to certain principles. And possibly at the beginning, you may want a lot of explanations. And then over time, we will just trust by requiring very little information behind the decision that is suggesting you to do. There is a lot of emphasis on explanations, especially on domains where you have some liability, like in the healthcare domain, or where there is liability, meaning that the system human plus machine, or the human, if it's the one is going to be liable, it has to explain why it did something. And as you know, in Europe, there recently was a regulation that said that by 2018, every system that is going to make decisions that significantly affect the life of some human it has to provide explanations why that decision was made. Of course, explanation can mean everything and nothing. You know, you want explanations that are understandable to the target users. If it has to explain to the patient, if you are in an healthcare domain, it's one thing. If it has to explain to the doctor, it's another thing. If it has to explain to the person who developed the system, it's another thing. So, of course, explanation may mean different things. But again, I think this is true for some people think that this business of building trust, explanation is mostly to do with autonomous systems, but I really think it has a lot to do also, and especially with human-machine collaboration, because in that symbiosis of human and machines is where, you know, you want a very effective and seamless teamwork. And without trusting each other, you will not be able to get that. So the ethical embodied decision-making, putting all these ingredients together, is what I think is the vision for the future, the intersection of these three areas, decision-making, AI ethics, and embodied cognitive systems. But in fact, you need research in any of the two sub-areas of two things alone. So you need research on ethics in decision systems, which values, how do you represent the values. For example, in this area, I've worked with other people in this room, and also many others have worked on this. In knowledge representation, decision-making is mostly based on preferences of individuals and groups. So we want to understand whether these models of preferences that people have developed in AI for many years, they can be also adapted and reused also for expressing ethical theories, because ethical theories, after all, they are defining more or less the same way the preferences are defining, which is a partial or a total order over the possible decision that one can make. And we also have to work on, of course, embodied decision-making, so interaction in an embodied environment. And I didn't write that, but possibly there is also work to do in AI ethics and embodied cognitive systems without even thinking of decision-making. But in general, I think it's a very multifaceted approach where, besides the technological part and the AI experts part, we need to talk also in a very multidisciplinary environment. I will skip the part on the preferences and more details, but I can give the slides if it's useful. And then I will just finish with some of the initiatives that are ongoing and that may be related to this event and also to what we have been talking today. So this embedding ethical principles in decision support systems is also a subject of a project that I am doing together with other people, funded by the Future of Life Institute. And of course, in that project, we focus on collective decision-making, so helping people make decisions. And we don't focus that much on embodied, so we are working in the top part of that picture that I showed you. But there are really a lot of interesting issues and ideas there. So it's really an area of a lot of scientific advance and very promising. The second one is an IEEE global initiative. IEEE, you know, is a very large association of engineers and developers all over the world, and they're really interested into the issues that we are interested in today, all of us. And they are planning to, you know, think about standards for designing systems that process ethical values and so on. Another thing is the company that I joined, IBM. I joined IBM 1 year ago, and I brought this interest into ethics into the company, and I think that the company supported that very much. Of course, IBM is not that it was not doing things ethically before me joining. It has done things, you know, in a responsible way for 110 years, but I think that now things are more explicitly handled with various initiatives, white papers, and so on, and what happened? Oh, sorry. The last thing is the partnership on AI. So the partnership on AI, as I mentioned before, is an initiative that was launched 2 weeks ago, maybe, with 5 companies that put together their interest into developing and deploying AI in the most beneficial way for people and society. That's the name, Partnership of AI to Benefit People and Society. And the founders are 5 companies, but actually it is going to be open to everybody, non-corporate environments of any kind, as scientific associations, professional associations, other companies that actually don't do AI, but deploy AI to the real world, for example, or even non-profit organizations and many, many other stakeholders. Everything that comes to mind is invited to come and to discuss these issues of what it means to deploy AI in the real world, to develop it in the ethical way, and also to make sure that it behaves ethically when it's deployed in the real world.
Great. Yeah. Thank you so much.
Thank you very much for your talk. My name is Carola Kreitmeyer. I'm from Stanford. I think there might be a little bit of a tension in what you're talking about with respect to the embodied environments. And I'm going to try and put this all in one question, although it's sort of 2 questions. So in this embodied environment, it seems to me, so I wanted to get your input on whether you think there is something lost in this kind of an environment, because you might think that humans are sort of evolved, that we have these adaptive abilities to exist in a natural environment, and that when we transition into this embodied environment, that there is maybe either a sense of authenticity that is lost or some sort of aesthetic value that is lost. And the conflict I see with that is, so now I'm transitioning to the second part of my question, your discussion of how we ought to embed sort of not only moral principles, but even social norms in our AI, I think necessarily something like the embodied environment violates social norms, because we don't accept it when people stare at us 24/7 and deduce by our little twitches in our faces what it is we're thinking about. So I think there's a tension there that on one side it sounds like you want to maintain kind of a regular human social norm environment, but on the other side this is a very artificial, it's in the name, environment. Thank you.
I understand. Yeah, okay. So, well, the fact is that, for the first question, I think, most of the time we are inside an environment. So I don't feel this environment artificial, with the room where we are right now, I don't feel it as artificial, because most of the time, not in a room like that, but either in my office or in a meeting room with other people or in a conference room. So I'm not suggesting to put people in a special, very strange environment, which is all dark and they have goggles to look at each other or something. But I envision a scenario where people are in their own natural environment, however natural you feel is this conference room. The room is equipped with possibly as the least invasive things as possible to actually support those people, those individuals, to do whatever task they are doing in that environment already. So pilots are already in the cockpit of a plane. I'm not building another environment for them, and that's my whole point. I don't want them to open a laptop when there is a crisis on the plane and they need to understand where they do an emergency landing. I want the environment to help them. So I think this is actually more natural than just having to use a tool which is separated from the environment. So I don't see that as unnatural, because I want the normal environment to support this decision-making system. And the second part of the question, which has to do with violating social norms, conflict with social norms, again, I think that, I think that there could be that tension if the environment becomes too invasive, okay, in order to help more the decision process. So I think that, yes, there could be a way to, to draw a line to when the environment is a support to the decision making and when the environment is not. I mean, the support, is becoming too much, and then the people should be able to, to use their social norms, including how they interact naturally among them.
Hi. First, I just want to quickly address that point. Games are about suspension of human norms, and it happens all the time. And so creating a game environment in the embodied environment will, I think, bypass that problem. And there's also a question of new social norms being needed, which is about human evolution. So the question I have for you is, I heard a focus, there's human self to machine, human few to machine, human many to machine dialogue, and that's the subject of your focus. Now, my question is the following also a subject of your focus and your research? Many to many human dialogue, many to self or many to few human dialogue, where the technology, the embodied environment, is facilitating the existing human dialogue rather than the dialogue being between the machine and the human?
Yeah, okay, that's a very interesting question. So I think there is a role for machines to help people resolve conflicts, possible conflicts in interacting among them. As was mentioning, there is a role for machines to alert humans or groups of humans when there is some deviation with respect to norms of laws or ethical principles or professional codes. So in the same way, I think there could be a role in helping them resolve, interaction glitches, let's say. Yeah.
Last question.
People are identifying themselves. I'm Frances Kam from Harvard University. I thought it might be useful for you to consider an issue that some philosophers have focused on, namely, to what extent can one trust and rely on the opinion of a so-called expert when one makes a decision, though one doesn't understand and agree with the expert. So certainly when you hire an accountant or a plumber, okay, after a while you see that their results have been good, you don't know much about it, you don't understand why they're doing this right now, but you go with their view. But some people have argued that in the area of ethics, it would be wrong, morally wrong, to trust and rely on what has even been an dependable, trustworthy ethical system in the past. If you still do not agree with that entity, they provide you with an explanation, you don't see why they think that is an explanation. Some people have argued that in the area of ethics in particular, unlike other areas of knowledge, it would be morally wrong to do what you in good conscience do not think is the right thing to do. Yeah. And I'm just wondering if that will affect the degree to which we can rely on, let us say, the ethical expertise, so to speak, of an AI system. There is a whole literature on this, and I just I hope it will be constructive for people to look at it.
Of course, I agree that, what's important is that the system helping you make a decision maybe alerts you that that decision involves some ethical dilemma, and it tells you, how it explains you why it's suggesting you to make a certain decision because it's following some ethical principles. You may not agree, and the important thing that you are aware the line of reasoning that AI system is using in order to suggest you that decision. But the final decision maker is the human, and the human is supported in his decision, even if the decision is different from what is suggested by the AI system. But the AI system has helped the human, at least, to structure the space of the possible decision and then to suggest something according to the ethical principle that the AI system has. But maybe it's not the same as, maybe not the same social norms or same of the doctor, but the doctor at least has, I think even in that case, it has been helped in making a decision, even if the decision is different from what is suggested. So yeah, I mean, it's very interesting, and I would like to see more on that.
Great, let's thank Francesca for So lastly, we have Professor Peter Relton. He is the Gregory S. Kafka Distinguished University Professor and John Stevenson Parent Professor of Philosophy at the University of Michigan, where he has taught since 1979. He's the author of the book Facts, Norms, and Values, and the collection of, which is a collection of his major papers in ethics, and a co-editor with Steve Darwall and Alan Gibbard of Moral Discourse and Practice, Some Philosophical Approaches. And today he's going to talk about machine morality, building, or learning. Thank you. Let's welcome.
Well, the first thing you're going to see is that moral philosophers don't have very interesting looking slides. And so I'll have to ask you to forgive me for that. And I know it's late in the day and you've already had an enormous amount set before you. So I'll try to make this as painless as I can. And I hope to say something that people can disagree with also. I call it building or learning. And really what I'm going to talk about is building for learning. I was interested to learn that we're supposed to talk about the short run today, and it's a big mistake to ask philosophers to think hard about the short run. But if I do think about it, I guess one thing that occurs to me is that if we in humans and AI agents, and I'm really focusing on artificial intelligent agents as opposed to sort of other kinds of systems, for us to work together, aware of the limitations of AI as it now stands, but somehow mindful of the need for the development of AI's potential to make this a better place, and to do that somehow at a pace that does not outstrip our capacity to regulate it or its capacity to regulate itself. It might seem enough just to teach AI agents what we want and design them to deliver this and no more. Then the challenge would be keeping them on task. With all the dangers of hacking and security, I hope I get some reassurance on this point. But this can't be the best model for realizing the promise or avoiding the threat of artificial intelligence, because our own wants and values, certainly mine, require critical assessment and not just replication and implementation. And as we saw from the previous talk, AI is already helping us figure out what we might want as individuals, or as doctors, or perhaps in social decision-making, helping us to gain and share and use knowledge and experience to approximate better informed preferences and policies, and in the small and in such larger questions as how to regulate the economy. So we don't want just to download whatever we want onto these systems. And similarly, we're going to be living with robotic agents, it seems, increasingly, and as I get older, I'm being told that that's perhaps my fate. And the more that that goes on, the more that they'll need to be actually sensitive to what's going on in our lives. And that will require them to be more autonomous because, as we know, you can't make a very good companion out of a creature that is just a prosthesis for your own will and beliefs. Okay, so this actually sounds kind of familiar. We've already been developing ways of tackling such problems, I think, since this is the trajectory of human moral development. AI systems, as we now understand them, lack much of the equipment with which humans take on the task of moral development. They lack, as far as we can tell, consciousness. They don't seem to have feeling or caring in the same way humans do. They don't seem to have the same capacity to appreciate value or for respect. And so you might think, well, from the outset, we're up the creek. These AI systems can't do anything like morality. All we could do is just teach them constraints and rules. And it has been argued that the kind of intelligence currently in view in artificial intelligence work, namely the capacity to predict and simulate, to make choices relative to well-defined objectives, to learn from experience how to do this better, that's essentially orthogonal to morality. And that might be right. But as we increasingly interact with such systems and allow them to participate in our own lives in decision-making, the question of what it would take for them to be intelligent at that kind of existence might get a somewhat different answer than simple orthogonality. You know, that's the question I put to myself after this morning's session, and I'm trying to figure out how a philosopher might say something about it. So, and when we think about the development of moral autonomy in humans, a key feature is that morality is developed in a social context, that we learn morality, so to speak, in a social context, and our capacity to form and realize whatever values we have on the basis of experience is integrated into our social existence. And so thinking about how artificial systems might acquire morality should be thinking of them as social creatures and not simply as creatures who are intelligent, but who are socially intelligent. Now, here's a simple model, and this is one thing philosophy can contribute. We're big on simple models. So as we saw this morning, very plausibly, self-preservation would emerge as a sub-goal of an intelligent system seeking to realize many given objectives. It's like the warning we get on airplanes that parents should put on the oxygen mask first in order to be able to assist the infant. Self-preserving systems would emerge as a part of their job of delivering whatever objectives we set. Now, Hobbes argued that creatures capable of self-regulation and seeking to preserve themselves, if intelligent, could, by playing out the consequences of non-cooperation, come to realize that a social pact of mutual restraint and cooperation to which they could, if self-regulating, hold themselves, would actually be a subpart of their most promising general-purpose problem-solving plans. That is to say, if you want general-purpose problem-solving and you're a creature like this and you're amidst other creatures like this, you would, as a good intelligent Hobbesian agent, realize the value of entering into these kinds of mutual restrictions. And so even from the task of self-preservation, Hobbes points out, we get something that takes some of the shape of morality. And as we enter autonomously into relations with these systems, systems capable of learning from experience to become better at such interaction, we could see perhaps how behaving intelligently in such situations could involve the formation of social relations that bear many of the hallmarks of morality. This is not a claim that such systems would be moral agents, but rather that their intelligence could lead them to discover important functions of interpersonal ethics as they develop greater autonomy and wider goals. That is to say, as they become more intelligent, it won't simply be orthogonal to their moral development insofar as they actually are intelligent and successfully realizing their goals. So in the short run, what would that mean? I don't know. I suppose it would mean attempting to try to ensure that such systems are multiple, that we have multiple AI agents around, and that insofar as possible, they have somewhat similar levels of advancement and resources, and they can then learn from their interactions with ourselves and with others how it is that social morality can emerge from the kind of Hobbesian mechanism just described. Now, should we be afraid of opportunistic invaders? And of course, that's right. Some of these will be humans, hackers, and some of them will be machines, perhaps, that become opportunistic. But what the Hobbesian will argue is that this is actually a familiar problem, and a society of intelligent cooperators can be resistant to such invasion. That is to say, if you want to inoculate us against the possibility of this kind of manipulative invasion, it's actually more efficient to make us moral than to make us cunning. And so in that sense, although this example is completely anthropomorphic, what we have is a recipe for thinking of building AI systems that become, in their development and their action and their cooperation, something like proto-moral agents. We'd first have to build AI systems that could impute representations and goals to humans and their fellow systems. You have to have that for this kind of mechanism to work. And they'd have to have something like the ability to do theory of mind, functionally understood now, and enter this kind of information into their own simulations and decision-making. And you all here in this room know more about the possibilities for this than I do. But strategic considerations apart, this capacity is something that such systems will need for other purposes as well, for general purpose problem solving as co-workers, companions, research staffs, drivers, and teachers, and even for their own prudential deliberation. So as a start, we might try working in machine ethics the way that the intellectual progenitors of the current developments in artificial intelligence worked in machine vision. That is, looking for inspiration to the actual model that we have thanks to natural selection. So what do we know about moral development, from moral development, about what it is to acquire and learn, to think and act from something like a moral point of view? And this is the progenitor of the idea of moral learning. And this is just an attempt to impress you that I'm not entirely making this up. We have started trying to work on the question of moral learning, bringing together people in various different disciplines, trying to reconceive moral development as a learning problem. And here's a hint as to what we might hope for. So the blue areas are the default network of the brain, which is active when you're not engaged on a specific concentrated task. And here are some of the functions that are attributed to the default system: autobiographical memory, envisioning the future, theory of mind, and moral decision-making. So we should expect that those actually involve the same kinds of competencies if agents that get to be moral decision-makers, like human adults, also have to be able to do theory of mind, have to envision the future, and have to have autobiographical memory. And indeed, they use this system, this capacity to model and simulate, in moral decision-making. And that's a very different picture from the picture one sometimes gets of moral decision-making emerging from just some basic drives that we have, some basic attitudes, something that we've just been instilled into by social conditioning. This makes it look like it's part and parcel of general-purpose intelligent problem-solving. Okay, so keep in mind that we're still working on the question of intelligence as understood in this conference so far, that is, capacity to predict and general-purpose problem-solving. We're not asking for a fully fledged moral agent. And we need to ask what kinds of representations such agents would have to acquire moral competency and how they might acquire them. Now, this brings me to another potential contribution of morality, philosophical morality at any rate. The idea of a moral point of view as a distinctive point of view on the decisions that one makes, the interactions one has on society and so on, is not a parochial position within ethics. We find it in the Kantian tradition. It starts out with Rousseau. It leads to contemporary neo-Kantians, to contractualism, for example, the original position in Rawls. Thomas Nagel's view from nowhere is in some sense a moral point of view. The utilitarian tradition, starting with Hume and Smith, coming into the present with social choice theory and figures like Harsanyi and Gibbard. In other words, the idea that there is a kind of information that's needed for moral decision-making that involves a point of view that's distinct from the point of view of prudence or the point of view of aesthetics or the point of view of power. That's itself a doctrine that helps us get some fix on the idea of what kinds of representations morality might need. Among other things, it would need to be something that could be non-perspectival. It would have to have abstraction, the capacity to generalize, would have hierarchical structure. It would have to be modal. It would have to be projectable and supporting planning. It would have to have general consistency and treat like cases alike. Now, those features of the moral point of view, I'm going to argue, are quite generic features that intelligent creatures seek representations to satisfy. The moral point of view additionally has the features that it accords inherent moral significance to harms and benefits to others as well as the self, and to how these harms or benefits are distributed. So I'm going to talk first about the first four features and then about the last two. So we now have reason to believe that spatial and causal representation, as it actually comes up in humans, involves learning relations with these features of hierarchy, abstraction, modality, and non-perspectival. These seem to emerge by processes that approximate normative principles, for example, Bayesian conditionalization, and that are used in model-based simulation and planning. And so agents, like little humans, can grow up with model-based causal reasoning that conforms reasonably well to normative models of inference. We also have evidence of normatively appropriate processes meeting these conditions in areas such as theory of mind, linguistic representation, and epistemic evaluations of adults. Children have to make up their mind whom to trust. So in these respects, we have already the idea that creatures designed to grow up in a world like ours will generate these kinds of hierarchical, abstract, non-perspectival representations. Why would non-perspectival representations be important? Why don't we just have the subjective point of view? And the answer is that if you're a social creature, a great deal of what you need to know you can only learn from observing third-party interactions. And moreover, if you understand what's going on in third-party interactions, you get a better explanatory and predictive model of the world than if you try to refer everything to yourself. If, for example, you observe that someone plays favorites, then that's going to be important even when you happen to be the favorite. So in that sense, then the task of generating a good generative model of the social world will involve already creating these non-perspectival representations. They possess the kind of objectivity that we need for moral decision-making. And in this case, they've been arrived at not through the challenge of ethics as such, but through the challenge of general social intelligence. We also have evidence of similar kinds of non-perspectival evaluative representations in the case of morally relevant features. Willingness to help, helpfulness, hindering, sharing fairly and unfairly. Within the first 6 to 20 months, we find infants having preferences not only for helpers, but for hinderers that hinder hinderers. They are obviously constructing fairly rich representations of the intentional environment and evaluating them even when these interactions don't involve them. And most of these phenomena can be observed early enough, for example, theory of mind issues, that it is implausible to attribute them to parental teaching and social reinforcement. So we have to think that it wasn't that these were beaten into the children or that they were reinforced by a socially or parentally designed regime. Rather, it seems as if the infant has extracted a compositional structure from the social environment around it and generated evaluative models of that, gaining accuracy through the generation of expectations. Okay, now what's interesting is that this seems to be a spontaneous process. And one nice example of that is the fact that by age 3 or 4, infants already are capable of distinguishing moral from conventional or practical violations. And that's interesting because it seems unlikely that parents will go around teaching children that actually they should disobey authority figures and instead act on moral considerations when they're deciding whether to cooperate. Psychopaths, for example, who experience difficulty in mastering this distinction, appear now to suffer from a learning disability with respect to their capacity to represent negative future outcomes. So, if we think of intelligence as problem solving and the need for generative models that reflect states of affairs in this non-perspectival way, that might afford us something like the beginnings of a functional morality that would be more than simple orthogonality predicts. Okay, well, what would functional morality look like? Intelligent representation of costs and benefits relative to goals, which one could get from such a system, is not caring whether the goals are realized. Ordinary infants are motivated by these kinds of representations, and one of the important ways in which they do that seems to be empathic simulation, using their own affective system. Now, this process combines a capacity to represent with a capacity to appreciate value in some measure and to be motivated to behave accordingly. And we don't have anything like that in view thus far. What we have are intelligent systems that are good at extracting perhaps the intentional structure of situations, the goals of those around, and representing those goals in a non-perspectival way, but not in a way that's effective. So can we build anything like that, anything like functional affect to underwrite functional empathy? As a first approximation, that would be a matter of assigning decision weights to gains or losses in the goal realizations of others. If you can represent the goals, if you can predict the outcomes, you can represent how well the goals are realized, and you can therefore pay attention to the goal realization in general, non-perspectively, and you can pay attention to the distribution. And this would involve something like a capacity to translate others' goals into the goals of the system, treating them as ends for oneself in this functional sense. A system that robustly had such a capacity would be able to learn through experience, as a child does, how to think and act in ways that would be beneficial for those with whom it interacts. It would perhaps be able to strike Hobbesian bargains with those with whom it interacts, and to emerge, therefore, from these interactions with something like the social structures of a functioning morality. Behavioral rules might be a starting point for such systems, but if we really want behavior that's sensitive to morally relevant considerations in an open-ended array of contexts, what we'll have to have are creatures that are directly sensitive to morally relevant considerations in the context. Systems like this would have a capacity for effective planning. Indeed, as Thomas Nagel pointed out years ago in The Possibility of Altruism, the capacity for effective planning requires the representation of goals that aren't one's current goals in much the same sense, and giving those a role in one's current behavior. So you're treating yourself as an end and a continuing entity over time in that functional sense. So that's why the default network and these functions tend to overlap in this way. And that's how functional empathy permits a kind of critical perspective on one's own current goals, as well as a capacity to respond to the goals of others. So it could enable an AI system not to cooperate with someone, for example, seeking to harm others, or to warn us when we are making mistakes in our simulation or estimation of the effects of what we're doing. Now, these are important forms of autonomy and grounds for greater confidence in these systems as we grow to live with them. And so, in this sense, maybe the path for building artificial intelligence that we can trust is a path toward building these functional moral agents. We don't want to lose ourselves in this. Functional empathy is not empathic concern. It's not a sense of the value of goals. It's not a concern that cares about whether the goals are realized, that they matter in that sense. But it is something that is functionally similar to morality in the sense that it gives weight to others' goals as such and can pick these up from the environment and adjust its behavior accordingly. AI systems will need to do this not only to work with us, but to work with each other so that they can rely upon each other and communicate in a manner that will develop some shared trust. So in the long run, we face problems of how much development of these kinds would in fact give AI systems more than just functional autonomy or functional morality. Could we build them with affect, with interests, with concerns, with consciousness? I have no knowledge of decent theories for answering these questions, but there does seem to be a decent theoretical basis for thinking that the development of functional capacities for representation and action in accord with the constraints of a moral point of view, not building our values into machines, but allowing values to learn, much as infants learn, how to act in light of values that are present in situations, viewed impartially, might be a good strategy for raising AI systems to act as responsible adult members of our communities. Thank you.
Eliezer Yudkowsky here, a fan of your meta-ethics. Also co-founder of the Machine Intelligence Research Institute. There's a lot more in this talk than I can begin to comment on. A couple of issues that come to mind as sort of like highest priority would be, first, if you are making systems that are sort of like trying to satisfy human desires, you probably want to go a little further than that up the sophistication hierarchy and say, like, what would this person want if they knew everything the AI knew? Like, what would they want if they could think for as long a time as the AI, and sort of like generally move a bit closer to the ideal advisor theories if we don't want to create a classic science fictional disastrous dystopia situation. The other thing is, I'm a co-author in a paper called Robust Cooperation in the Prisoner's Dilemma, Program Equilibrium via Provability Logic, and we showed that two programs can cooperate with each other if they know each other's source code in like a nicely general way. Okay. And what this suggests to me is that the sort of natural cooperative equilibrium among AIs seems quite likely to go through knowledge of each other's source code, which suggests that humans might be frozen out of it. You can't prove that the human will cooperate with you if you cooperate with the human. In general, I think when you try to sort of like directly sort of like run past the orthogonality thesis by deriving a nice behavior as a purely instrumental strategy, a lot of times what happens is that the instrumental strategy you get is like not quite what you want. So like they might cooperate with each other but not cooperate with us.
Yeah,
good.
That's all. So thank you very much for that. Yeah, I am I'm a believer, I guess, and I tried to suggest this at the outset, that as we interact with these intelligence systems, we want to have the criticism of our own current preferences, and indeed something like the idea of what we would want if we had more information and greater experience is part of that notion. So that's part of the promise of AI. Now, what you're describing is also part of the threat, namely they could learn to cooperate with themselves but not with us. And I'm really not trying to show that you can prove that a certain kind of dynamic will result in a nice equilibrium. I'm suggesting that it would be advantageous for these systems, not only with regard to their interaction amongst themselves, but their interactions with us, for the realization of the goals that they have, to learn how to cooperate with these humans. And so in that sense, the claim is meant to be a fairly general claim. How could they be good at cooperating with humans? Well, to the extent that they're good at representing our goals and intentions and so on, they can be good at cooperating. Now, that could also make them good at manipulating. And so the question is, if you're trying to build a general intelligence that's good at problem solving, this goes back to a point Jan LeCun made, the targeted manipulator, and we know these people in our midst, the targeted manipulator has a long-standing reputation of not succeeding in just those tasks, because the targeted manipulator has exactly the same problem with regard to his or her own, now not proximate, but distal preferences.
Thank you very much for your thorough and illuminating talk. I have a very basic question. So the Hobbesian strategy towards proto-morality works or requires the drive to self-preservation. And we might think that in humans, this drive is provided by something like biological evolution. So I just wanted to hear your input on why we should think that in artificial intelligence there would be a similar drive towards self-preservation. Because earlier today we heard someone mention that, does it matter if we turn them off? We'll know if they don't care. And you might think that even in humans, sometimes the drive to self-preservation is overridden, for instance, in suicide bombers or the like.
Right. Yes. The idea here is not that they care whether they persist over time. That would be a further step down the road, and I have no idea how to take those steps. The idea, rather, is that insofar as they have objectives and goals which they need to realize, for whatever reason, they're either goals that have been attributed to the system or assigned to the system, generated by the system, it's necessary for the system, in order to accomplish those, to achieve certain other things. And one such accomplishment is to persist at least long enough for the goal to be realized. And so that makes self-preservation into something like an instrumental goal, a sub-goal of plans of other kinds. And so that's not caring about whether you exist, it's not caring about the goals, the longer-term goals, but it is being designed so that functionally one takes seriously the conditions under which one can best continue one's own existence. And in that sense, it puts them in a strategic situation that's similar to the Hobbesian dilemma, even without a biological drive.
Question
there? Yeah. So as you try to get something like morality out of Hobbesian-type issues, it seems a lot of the time what you wind up in is more like tribalism, where you have the distinct tribe within which there's cooperation. And across history, that kind of looks more like the attractor. So is there a way to not wind up there as you try to build this way?
Right. Yeah, very good. So I'm really not trying to get morality out of Hobbes. What I'm hoping to be able to show is that there can be ways in which parts of morality can be gotten from conditions of social creatures who are acting intelligently to realize their goals. That's by no means going to take us entirely as far as morality. Now, the question about tribes is quite interesting. The same thing is said about humans, that humans are tribal creatures. There's some good evidence that actually our hunter-gatherer ancestors lived in groups that were fairly fluid, that there was marriage across groups, that the individuals would change groups depending upon various conditions or times of the year. And so it looks as if building a generic capacity to represent others, not a capacity that's mediated by your group or your own interest, actually would be favored as a model by which they would understand their social world, because they would be entering into groups where there were strangers, they would be having people in their groups who were strangers, and in order to understand and interact with such individuals, they can't just represent them via the mediation of their interests or their group's interests. And so in that sense, it might be a fact about us. It's a fascinating fact about humans that we engage in this large-scale cooperation with strangers. One explanation of that is that capacity to engage in large-scale cooperative exchanges it enables so many other possibilities that is highly advantageous, and the same thing would be true of systems that were artificial.
So let's get one more question from Stuart Russell, and then get the other panelists.
So I think Hobbes was imagining a human being who would have to accede to the goals of the group in order to succeed himself or herself. But if we were a conference of ants, right, and we're sitting here talking about
a conference of ants.
Ants, yeah. So we're sitting here talking about ant goals and ant preferences, and then there's an ant philosopher who's talking about a human being who, in order for that human to succeed, they're going to have to go along with the goals of the ants and kind of help the ants in order for the human to succeed. That would kind of be a bit silly, right? I mean, that's not how human-ant relations have evolved over time. So that's sort of one point. Another point, you're assuming that the entity that is supposed to learn about human goals and to some extent give them decision weight in its own decision making has goals and objectives of its own. But that's precisely, I think, what Nick Bostrom is talking about. His paperclip maximizer has a goal, and it might well be that in its early stages of its own development, it needs the help of humans to do that. So it learns about human goals and all the rest, and is nice to the humans and so on and so forth. But its goal is to maximize paperclips, and so in the long run, the humans are all turned into paperclips and everything else. So I think it doesn't address the fundamental problem that if you give machines of arbitrary intelligence goals and objectives of their own, or they have them of their own, then anything they do to cooperate with humans is just window dressing.
Well, I hope not. One of the interesting things in this vicinity is that we're going to have, these systems will become autonomous whether we like it or not in many ways. If they're as powerful and intelligent as is suggested, if they're as capable, and this I'm just taking your word for it as to what they might accomplish, these systems are going to acquire autonomy, and they're going to acquire the ability to form goals. And so the question is, given that we can't lay down a law to specify in advance what it is that would be appropriate behavior, and we don't even know what that law would be like that would regulate behavior in all contexts, what's the best we can do to design a system that is going to be sensitive to the relevant variables in the world in such a way that even in an open-ended range of environments and interactions, they could be a companion, a co-worker, they could be someone who is inspires enough trust for us to continue the development of artificial intelligence. And in that sense, we are looking at a bunch of considerations which aren't tremendously different from the considerations of other intelligent agents. Ants are not a very good example because, I would dearly love to be able to say to ants, look, you can build all the ant tribes you want. I'll go out there and I'll give you chips of wood. Just don't start building your houses in my porch or in my rafters. And they never have been able to strike the Hobbesian bargain, and as a result, ants are excluded from my house.
Great. Well, on that note, let's thank Peter for... Right. So first, I'd like to see if the panelists have questions for each other. Putting you on the spot.
Maybe we
okay. If not, okay,
continue with question for the other.
Okay. No questions over there.
Hi there. I have a question for Francesca. Your speak was very interesting, and the idea of smart machines obviously has a lot of benefits to it, but I was wondering of the implications on a larger stance. On a larger stance, looking at the implications going all the way to childhood, especially just looking at. Sorry, I'm re-looking at my notes that I wrote. Okay. Just from the common notion that we learn from our mistakes. And so the idea that we are constantly, understanding that this technology is going to be implemented in society in a much larger aspect than we're simply talking about in medical or other infrastructure. Once this becomes a much more social environment that children are going to be interact with, the notion that there's a constant companion who is suggesting and telling us and teaching us what is the right and wrong things to do in every situation, it seems like there is a lack of our own personal development. And then I think that also begs the question on a larger conversation about originality and creativity. And if we do have these companions who are talking to us and suggesting based on an algorithm in which they are constantly developing, I am very curious about what your thoughts are in innovations and even artwork, and who is the owner of this idea. And also, sorry, one more thing is that, okay, yeah.
Okay, I think that's a very interesting question, and I don't have many answers, but I certainly see the danger if one brings this approach to the extreme, that everybody, including children, are going to be accompanied in their life, in their decision by some support system. Then, of course, there is a danger that creativity, learning by mistakes, and originality becomes a bit. But first of all, each one of these systems, I envision it as being personalized, so not the same for everybody. And second, I mean, it really brings again the this fact that I think that this whole, once we have in mind a certain vision as AI people, it's really a multidisciplinary approach. So psychologists, that know how children, evolve, can help us understand and mitigate those and possibly not have those negative effects, and help us understand if there is in the future a different way of growing up, of building our own, identity, which possibly is different from what we have now. I mean, I think that people, children that grow up now, they grow up in a very different environment, and they grow up in a very different way from when I grew up, when I was a child. Is this good or bad? I don't know. I mean, I think that there are experts not in AI, but in other disciplines that can help us understand the implications of what we do and of our visions that we can implement, but then, the implications should be taken into account. So thank you for this question.
Yeah, I had a few minor comments here. I mean, one of the more bizarre scenarios of how the AIs take over, so to speak, is that we have all these auto-suggestion things about, like we have auto-completes as we type things in. It's like the AI knows our, I'm a person who happens to collect a lot of data on myself. I've probably collected more data on myself than any other human, kind of bizarrely. And so I have all this personal analytics information. And so automated systems should be able to predict for me, what I should do. They may know better than me what I should do. And there may come a time when there's just a bunch of auto-suggestions that are coming up saying, you should take a drink of water now, you should do this, you should do that. Just like we follow our car GPSs, I think it is extremely likely that most of us will follow most of those auto-suggestions because they'll probably be pretty good suggestions. And I think that's kind of the soft way that kind of the AIs take over, so to speak. First comment. Second comment. is about creativity and so on. I think that people have this view that, you know, the deterministic underlying system, the programmed system, doesn't show originality and creativity. I think this is just not true. Good example of this, we made a thing many years ago called Wolfram Tones. It was during the cell phone ringtone craze. It still exists. You can go look at it on the web. It's a thing that generates music using simple cellular automata. And it basically goes out into the computational universe, and it tries to find, you know, it has heuristics to decide, you know, this is a hip-hop sounding cellular automaton or something. And it searches, you know, each cellular automaton is kind of interesting because it has a kind of an inner logic. It's like it's not just random noise, it has an idea underneath it, and that's sort of rendered in music, okay? So I thought, well, this is kind of an amusing thing, nobody's going to care about it. Turns out I run into all sorts of composers who say, I thought, you know, a computer can take the idea of a composer and render it. But instead what I hear from composers is, that's kind of a cool site that I go to get sort of creative ideas from which I then build a whole structure. And so the computer in that case is providing the creative spark, which is sort of a strange thing. My third quick comment perhaps is about this question about people learning, you know, what the children of the future will learn and how, people learn from the sort of what civilization has built up and the environment that we have built for ourselves and the natural world that exists. It's sort of interesting to see, as we see how kind of there are, in the sort of computational universe of possibilities, there's a lot of stuff that isn't realized by the natural world, certainly isn't realized by our civilization as it now exists. And it's sort of interesting to imagine what, as we get to explore more of that kind of computational universe, how our patterns of thought change considerably. And that's true, for example, in this sort of emergent concepts that arise in the insides of neural networks and so on.
Great. So we've got a lot of questions. I'm going to prioritize people who haven't spoken. So, you first.
Hi, everyone. My name is Ashok. No academic affiliation. Throughout this conference, and Dr. Wolfram and Dr. Rossi both mentioned rule-based systems for ethics. It strikes me that in human justice systems, the great majority of the brain power is spent on specific cases, thinking through the details of the different ethical principles that might apply. And rarely do we see humans spend nearly as much time coming up with rules, even to the extent of fancy legal jargon, getting very specific. So my question for you guys, and I know Mr. Wolfram mentioned this a little bit, talking about sensors and smart contracts, but how do we actually do the complex work of judging individual cases across different sort of ethical principles, especially in the context of the fact that most humans have a very pluralistic and often contradictory system of ethics?
I can try taking that. I think my view of what's possible is to take, existing laws and render them in some kind of symbolic form. Now, laws of different countries, different jurisdictions, and so on, they're going to disagree. Now, the question, when you say, let's make a contract, I think there's a famous case about chickens, as I recall, about a contract where somebody got a kind of chicken that wasn't the kind of chicken they thought they were going to get. And the question is, when you make a contract and you say, I'm going to get this type of chicken and it's described in this way, in today's world, it's a bunch of English words that say, or words in some natural language that say what the chicken is supposed to be like. In the world of the future, I would imagine it's much more that both parties will agree this machine learning system trained in this way will be the thing that decides whether it's that kind of chicken or that other kind of chicken. And I think that if both parties agree that that's what the contract is defined by this code that is this machine learning system that is going to distinguish chickens or whatever. I think that's I see that as being you can agree, both parties can agree the code is going to determine what happens. This is a longer question, and I'm not sure I got quite the import of what you were saying.
Last question. Who has the mic? Yeah, Gina.
So there's a question. Is this thing on? It's hard to tell. Okay,
Yeah.
thank you. This is a question for the whole panel, and it's about the way people today have been using the words we and our to talk about our values and things like that. And I'm wondering if that assumes a sort of commonality to human ethics that is maybe false. So what I have in mind here is the view many theorists have that Western European ethical traditions coming out of the Enlightenment are a sort of historical aberration, focusing on the individual, whereas in contrast, say, Sub-Saharan African ethics or East Asian ethics focus on communal harmony. If all of that's right then, and this has real implications for AI ethics and in questions like privacy and autonomy, so if all that's right, if that's a reasonable worry, I'm wondering what you think. Is it necessary before we come up with AI ethics that we seek some sort of convergence, some sort of agreement, global agreement on intercultural ethics, or do we just accept that AI moralities will develop independently in different pockets of the world where the money and the technology is there, and that in fact AI ethics are actually going to diverge and there'll be different ethical systems implemented in different machines?
Well, one reason for emphasizing something like an empathy mechanism is that it's a way of trying to get moral behavior, or functionally moral behavior, that isn't mediated by a higher order moral theory of a particular kind. And so therefore it can serve as a kind of constraint on how individuals interact, even when they have different moral theories. So this is also relevant to the question about how much rules matter. The suggestion would be that intelligent systems could be capable of spontaneous adjustment to each other's preferences, each other's values, looking at those under greater conditions of greater information, and adjusting their behavior in a way that can be mutually beneficial for them. And that doesn't require that we think we've got the right set of values right now. It requires that we think we could benefit from working together.
One comment perhaps on this. If you look at the world today, right, there's 7 billion people divided into roughly 200 countries. There's a question, can we, if we knew sort of the technology, communication mechanisms and so on of the world, can we on the back of an envelope derive that 7 billion people will organize themselves into roughly 200 countries? It's kind of a scary thing. We recently got data on sort of all historical country borders. There are about, I think, 1,300 sort of countries that have existed in history, roughly, from historical atlases and so on. And you look at an animation of how the countries of the world have evolved over time. And it looks just like something, soap bubbles popping and things, empire gets bigger, eventually it pops and so on. It's a funny process that I don't think we understand. But I think I have to say that the idea that we're going to have the one magic sort of AI constitution that governs them all, I don't see that, because I think this constitution has to be a reflection of our human values and so on, and we don't all have quite the same values, and I don't think we can. And I think that's, that would be my point of view on that.
Yeah, I definitely agree that there's never going to be one set of values, and maybe the long-term, vision is that we will adjust and, adjust to the fact that we don't have the same values, but we can interact, and we find it advantageous to, have an interaction with shared values. But also in the short term, I think there will be some things, some tasks where there is no set of universal values. So depending on the specific scenarios that you're going to consider, you will have values that are useful and in that particular task and scenario. But there will be other things like even self-driving cars, where even now with normal cars, not self-driving cars, even now, of course, there are different social norms and different ways of driving all over the world, but to sell a car that can be sold all over the world, you have to pass a certain threshold of safety constraints. And all the cars have to pass that threshold. And then, you can improve on one or another aspect, but all the cars have to pass a certain threshold. So I think that in the future, all the self-driving cars will have to pass a certain threshold, which can be tested or, explained or, evaluated in some way. And then things can be different from one to another one. So in that scenario, I see the need for a basic universality for lower, low threshold of basic values which are shared. But in another scenarios, I see very specific, values in each.
Can I just say one totally bizarre point? I just
go ahead.
For fun. I mean, this question of sort of what the future of civilization is, and we've got all these entities which, let's say, they're sort of disembodied souls in our kind of box of 1 trillion souls, or a box of. So there's this kind of a funny thing, because when you have entities like that that can replicate in arbitrary numbers, this question of how where you get these kind of clumps of common values gets very weird, because we humans seem to like communities where there are multiple ones of us, so to speak. We don't just want to be one human on our own, but it's kind of a funny thing to think about. When you can expand without bound, and yet you have to make clumps to make things meaningful. How that works, and it kind of gets one into kind of thinking about transfinite numbers of souls and so on, and let's not go there.
So, let's thank all the panelists for a really wonderful discussions. Thank you all for coming. That was a great first day, and we'll see you again tomorrow.
We'll just stop the applause.